Okay, so picking up where we left off, the probability that a randomly selected 24-year-old male will survive in a year is approximately 0.9986. What is the probability that 3 randomly selected males will survive? So, 0.9986 is survival. These are considered independent because we're assuming that they're not friends or anything and they're not going around everywhere together. So it's 0.9986, so let's use our boxes. So this is person 1, 0.9986 chance. Person 2, 0.9986, and box 3 is 0.9986. So each one has that chance to live, so that's a 0.9986 raised to the third, which is 0.9986 raised to the third power is a 0.9958 chance that all 3 of them lived randomly selected. Okay, so it's pretty high, and I mean, it shouldn't be expected for anybody to die at that age. Obviously, there are accidents and craziness that goes on, but the next part of the question says, what if 20 people are selected instead of 3? So if we do 20, this was part A, this is part B. This guy has a 9986. The next guy has a 0.9986. Well, I'm not going to write all of them, but we're going to stop at 0.9986. And we have 0.9986 to the 20th power, which is 0.9986 raised to the 20th. It's about a 97% chance. 2, 4. That all 20 people live. So as you can see, it's pretty straightforward. You just calculate how many people, you raise it to a power, you see what happens for these people. Okay, now, let's go back. We're going to look at, oops, I didn't mean to do that. Let me delete this. Let's look at, compute the probability that at least one male out of 1,000 aged 24 years old will die during the course of the year. If the probability is 0.9986. The complement of this statement, okay. So we want to know at least one. So let's look at this real quick in detail, more detail than what I read. So we have probability of at least one of 1,000 die. Okay, so let's think about this. What does this mean? Well, there's 1,001 different outcomes. We have the probability that 0 people die, probability that 1 person dies, 2 people die, and then we have the probability that all 1,000 of them die, and that makes up 100%. Okay, so the probabilities will all add up to 1 if we took the decimal form and added them together. But the probability of at least 1 person dying, what does that mean? That means we're looking, if 1 person dies, are we good? Yeah, this one's good. This is okay. This is probability that 1 died. Probability of 2 people dying, well then at least 1 of them has died. Well, 2 technically, but at least 1 has died, so this one's good. But if no one dies, that's the only time where all of this doesn't make sense or it doesn't add up. So what we need to do is we have the probability of 0 people dying plus the probability of 0 of anybody who's not 0 dying. The complement of 0 dying is equal to 1. That would and just this whole section happens to be this thing. If 1 person dies, they fall into this category. If 2 people die, they fall into this category. So then the probability of 0 people dying is equal to 1 minus the probability of 0 complement. Okay? So, what does this mean? So let's think about this. The first person dying, so let's do our boxes real quick. Sorry, this is where it starts to get a little bit tricky. Oops. Okay, so let's do our boxes real quick. We'll do a couple of them. first person living, the probability of 0 people dying means everyone lives, so we have 0.9986. That's person 1. Person 2 is going to have the same chance. And then all the way to 1,000, they're all going to live. 9986. So this is 0.9986 to the 1,000. So what does that mean? That means we have to the 1,000. This is 0.2463. No, 2464. Okay, so the probability that everybody lives is 24.6% chance. So if we want to know the probability of at least one dying, oh, I guess I did that backwards. Here, this should be the opposite. This should be here, C, and this one should be that. Right, because we want to figure out this. We determined what this was. So this is P of 0 people dying. Sorry about that. I messed that up. Just correct it on your notes if you're taking notes. I just subtracted the wrong thing. We should have subtracted this one. And then we have 1 minus 0.2464, which is P of at least 1 dying, which is equal to, let me do this real quick, 1 minus 0.2464 is 0.7536. So there's a 75% chance that at least one person dies out of 1,000 with the rate that they have given us. So I hope that makes sense. Next one. So obviously this describes that. It would be impractical to compute it for each one, meaning if you did the probability of one person dying, then you do one person dies, the rest of them live, and then you'd have to look at all arrangements or different ways of which person it was that died. It could be person 1, it could be person 2, and so on and so forth, but that's too tedious. And so we use the complement. And then finally we have the rules of probability. The probability of any event must be between 0 and 1 inclusive, meaning including 0 and 1. If we let E denote any event, then P of 0 is less than or equal to P of E is less than or equal to 1. The sum of the probabilities of all outcomes in the sample space must equal 1. That is, if the sample space is equal to E1, E2, ... all the way to En, then P of E1 plus P of E2 plus P of En is equal to 1. If E and F are disjoint events, then P of E is equal, or F is equal to P of E plus F. If E and F are not disjoint, then it's P of E, P of E or F is equal to P of E plus F, P of F minus P of E and F, and so on and so forth, guys. I don't know why I'm reading all that. You can read it. I'm being dumb. Anyways, we've talked about each of these in the past couple of days of the videos. If you're struggling, remember you can come to Zoom meetings and talk to me and see what we can do. I hope that you guys are doing well. Just keep practicing, do your best. Reach out to me if you have questions. Don't wait till the end of the semester and beg me for a grade. I will not help you. Okay, thank you guys. Bye.